Have you ever worried about your electric car running out of juice on a long trip? Or maybe you've sighed at how long it takes to charge. What if I told you the future of EVs could mean charging in minutes, not hours, with batteries that are safer, cheaper, and lasts way longer? It sounds like science fiction, but it's closer than you think. Today, we are diving deep into two revolutionary technologies poised to change everything we know about electric vehicles: solid-state batteries and sodium-ion batteries. Let's start with the current champion, the lithium-ion battery. It's in your phone, your laptop, and almost every EV on the road today. They're great, but they have their limits. They use a liquid electrolyte to move ions between the anode and cathode. This liquid is flammable, which is why you hear about rare but scary battery fires. It also degrades over time, reducing your car's range, and it doesn't perform well in extreme cold. Plus, lithium and cobalt, key ingredients, are expensive and come with a whole lot of environmental and ethical baggage. This is where our first contender, the solid-state battery, steps in. Imagine replacing that flammable liquid electrolyte with a thin, stable slice of solid material, like a ceramic or a polymer. That's the core idea behind a solid-state battery. This simple change has massive implications. First up, safety. Without a flammable liquid, the risk of fire, you could theoretically puncture a solid-state battery and it wouldn't burst into flames. This allows engineers to pack cells closer together, creating what we call a higher energy density. What does higher energy density mean for you, the driver? A lot. It means you could get an EV with a 500, 600, or even 700-mile range on a single charge. Goodbye, range anxiety. And because these solid electrolytes are more stable, they can handle much faster charging. We're talking about charging your car from 10 to 80% in as little as 10 to 15 minutes. Picture pulling into a charging station, grabbing a coffee, and by the time you're back, your car is ready for another few hundred miles. That's the dream, right? Solid-state batteries also promise a much longer lifespan. They don't suffer from the same degradation issues as their liquid-filled cousins. A solid-state battery could potentially last for hundreds of thousands of miles, maybe even outlasting the car itself. This would be a huge win for both your wallet and the environment, as we wouldn't need to replace batteries as often. So, when can we get our hands on this miracle tech? Well, that's the multi-billion-dollar question. Companies like QuantumScape, Solid Power, and major automakers like Toyota, Volkswagen, and BMW are pouring huge amounts of money into research and development. Toyota, for example, has been a leader in this space for years and claims it could have solid-state batteries in some of its vehicles by 2027 or 2028. However, there are still significant hurdles. Manufacturing these batteries at scale is incredibly difficult and expensive. Creating perfect, defect-free layers of solid electrolyte just a few microns thick is a massive engineering challenge. Think of it like trying to make a perfectly smooth, continent-sized sheet of cling wrap without a single wrinkle. Any tiny imperfection can cause the battery to fail. The cost is another major barrier. Right now, making a solid-state battery is far more expensive than a traditional lithium-ion one. Until they can bring that cost down, it'll likely be reserved for high-end luxury EVs first. So while solid-state batteries are the long-term holy grail, what about a more immediate solution? This brings us to our second game-changer, the sodium-ion battery. As the name suggests, these batteries use sodium instead of lithium. Why is that a big deal? Well, take a look at a periodic table. Sodium is right below lithium. They behave in very similar ways chemically, which means we can adapt a lot of our existing lithium-ion battery manufacturing knowledge and equipment to make sodium-ion batteries. But the real magic of sodium is its abundance. Sodium is one of the most common elements on Earth. You find it everywhere, most famously in salt from the ocean. It's thousands of times more abundant than lithium and incredibly cheap to source. This could dramatically lower the cost of EV batteries. We could see truly affordable electric cars for the masses, not just as a premium option. Think about a reliable, practical EV, costing the same as a basic gasoline car. That's the potential of sodium-ion. Sodium-ion batteries also have other cool advantages. They perform exceptionally well in cold weather, a major weakness for lithium-ion. While your lithium-ion battery might lose a significant chunk of its range on a freezing winter day, a sodium-ion battery would hold up much better. They are also inherently safer. You can discharge a sodium-ion battery completely to 0 volts for transport or storage without damaging it, which is something you can't do with lithium-ion. This makes them much safer and easier to handle. Of course, there are trade-offs. The biggest one for sodium-ion right now is energy density. Sodium ions are physically larger and heavier than lithium ions. This means that, for the same size and weight, a sodium-ion battery currently stores less energy than a lithium-ion one. For a car, that translates to less range. This is why you're starting to see them appear in smaller, more affordable city cars in markets like China, where a 150 to 200-mile range is perfectly adequate for daily commuting. But the technology is improving at an incredible pace. Companies like CATL, the world's largest battery manufacturer, and BYD are already mass-producing sodium-ion batteries. They're even developing hybrid battery packs that mix sodium-ion cells with lithium-ion cells. This gives you the best of both worlds, the cost-effectiveness and cold-weather performance of sodium for everyday driving, with the higher energy density of lithium for that extra range when you need it. So, what does this all mean for the future of driving? It means we're not putting all our eggs in one basket. The future isn't just about one single battery technology winning out. It's about having the right battery for the right application. Imagine a future where high-performance, long-range, luxury sedans and trucks are powered by cutting-edge solid-state batteries. They'll offer incredible range and lightning-fast charging for those who need to cross continents. At the same time, affordable, compact city cars and delivery vehicles will run on cheap, safe, and durable sodium-ion batteries. This makes electric mobility accessible to everyone, not just a select few. The trusty lithium-ion battery will still be around, too, continuing to improve and finding its place in this diverse ecosystem. This multi-pronged approach is what will truly accelerate the transition to electric vehicles. By tackling the core issues of cost, safety, charging speed, and resource availability from different angles, we can build a more sustainable and accessible transportation system for everyone. The race is on, and the next decade is going to be incredibly exciting for battery technology. The silent, powerful, and clean electric car of the future might be powered by something you sprinkle on your food. The road ahead is electrifying, to say the least. From the promise of a 10-minute charge with solid-state to the dream of a truly affordable EV, thanks to Sodium-ion, the innovations happening in battery labs today will shape the cars we drive tomorrow. It's a fascinating journey, and we'll be here to cover every milestone along the way. Thanks for watching. What do you think is the most promising battery tech? Let me know down in the comments. And if you enjoyed this deep dive, don't forget to like this video and subscribe for more content on the future of technology and transportation. See you in the next one.